This is Euclid Book 5, Proposition number 8, and I had made a Euclid Book 5, Proposition 8, Part 1. I'm just going to do this complete this time, and we're going to take this very, very slowly here. The proposition is very long, so bear with me. Anyway, says let A, B, and C be unequal magnitudes. Well, We've talked about magnitudes many hundreds of times. Well, here's AB right here, and we have C down here, and as you can see, AB is not the same length as C. C is actually smaller. Okay? And we're going to let AB be the greater at this point. Okay, line AB is going to be greater than C. So AB is much longer than C. Well, I don't know, much longer, but it is longer than C. So once again, here's AB, and here's C. And then we're going to have another unequal magnitude. You see D here? D is not the same size as C. D is not the same size as AB. Okay? Now, we're going to say that the ratio of AB to D is greater than C to D. Okay? AB to D is greater than C to D. Okay, and that would be the equivalent of saying 3 to 2 is greater than 1 to 2. Alright, anyway, we're going to prove all this, and there are two cases on this one, and the way we're going to do this is, I kind of wish I had all my notes with me. That would have been nice. Oh, here they are. Here are my notes. Okay, the way we're going to do this, we're going to say that AE is 1/2, and I'm going to do this for you because if you were to do this by yourself, you'd really get confused, and we don't want you confused. So we're going to say that the length of AE is 1/2. Here's AE, and it's 1/2. BE is 1 1/4. There's 1 1/4 there. We're going to say that D is 3/4. There's D right there. We're going to say that C is 1 1/4. And as you can see here, the length of C in this particular case is also the same length as BE right here. So these two lengths, BE and C, are exactly the same. Alright, we're then going to go ahead and say that FG is the length of 1. Okay? And we're then going to say that GH is 2 1/2. The length of K is 2 1/2. The length of D down here, as we just said, was 3/4. The length of L is twice of D, which in this case is 1 1/2. The length of M is 3 times the size of D, so it's 2 1/4. And the length of N is going to be 4 times the size of D, which happens to be 3. Okay. Starting with the proof here, we're going to say that AE is less than EB. So AE here is not as long as BE here. Okay. BE is longer than AE. BE is longer than AE, obviously. Okay. Now, if we were to multiply the length of AE by 2, it would be greater than D. So FG is twice the length of AE. It also happens to be larger than D. Okay. And then we're going to multiply EB. We're going to multiply EB by 2. And when we do, we get the length of GH. So GH is twice as long as BE. Okay. And if we multiply the length of C by 2, we get the length of K. So the length of C times 2 is the length of K. Okay. And we've already established that L is twice the length of D, M is 3 times the length of D, and N is 4 times the length of D. And N, believe it or not, if we go down here, this length right here is longer than K. N is longer than K. Very important to know that. Alright. Since K is less than N, then K is still longer than M. Okay, here's M. K is longer than M, but K is shorter than N. Very important to know. And since FG is twice as long as AE, and GH is twice as long as EB, FG is the same, okay, FG is twice as long as AE as FH is of AB. So what we're saying here is that since FG is twice as long as BE, then FH right here is twice as long as AB. This line here is twice as long as AB. FG is twice as long as AE. K is twice as long as C. So FH is twice as long as AB, and K is twice as long as C. So what we're saying here is that FH here, this FH, is twice as long as AB. FH is twice as long as AB. FH twice as long as AB. Okay, we're going to do one more time. FH is twice as long as AB, and K is twice as long as C. All right. Therefore, FH and K are twice as long as AB and C. And since GH is twice as long as EB and K is twice as long as C, then EB must equal C. Well, let's go to EB. Here's BE right here, and it is the same length as C as we had established a long time ago. Therefore, GH is equal to K. Okay, the length of GH and the length of K are exactly the same size. But K is not less than M. So, K is not as... okay, K is longer than M. K here is longer than M. GH is longer than M. GH is longer than M. GH longer than M. And FG is greater than D. FG is greater than D. Therefore, FH is greater than D and M put together. So, FH here, the length of FH, this length right here is longer than the length of D plus the length of M. Now, if you were to put the length of D and the length of M together, you would get the length of N. Because remember, M is 3 times D, so 3 plus 1 equals 4, and therefore you have the entire length of N. Therefore, the length of FH is greater than N. The length of FH is greater than N. Here's FH up here. This length is greater than N. Okay. Now, K is not longer than N. FH is twice of AB. K is twice of C. FH is twice as long as AB, and K is twice as long as C. Therefore, AB has a greater ratio to D than C has to D. So we've proven case number 1. Now let's prove case number 2. Alright, this time, here's AE, okay, and it's going to be bigger than EB, right here. AE is longer than EB. But we first of all said that the length of BE must be equal to C. So BE is the same length as C. Alright. Now, if we were to multiply the length of BE twice, it would be greater than D. Now, we can go ahead and tell you this, because what we're going to do is we're going to have you in the second case make BE the length of 3/4, C the length of 3/4, D down here the length of 1 inch, GH would be the length right here, GH will be 1.5, AE would also be 1.5, FG will be 3, the length of FG is 3 inches, L is 2, M is 3, N is 4, okay, N is 4, and K is 1.5. This is 1.5 inches long right here. Okay. Now then, GH is twice the length of EB, and GH is longer than D. GH right here, this GH right here is longer than D. GH is twice the length of EB, FG is twice the length of AE, and K is twice the length of C. So, we start with GH right here, there's GH, and it is twice the length of BE. And we can then go on to say that FG, here's FG here, this FG is twice as long as AE. FG is twice as long as AE. And we can go on to say that K down here, here's K, is twice as long as C. We can go on to say that FH is twice as long as AB and K is twice as long as C. And N is 4 times the length of D, but it is the first one that is longer than FG. N down here is longer than FG. It's the first one of the D, L, and M and N lines. See these D, L, M, and M? Of these 4 lines right here, FG is bigger than the first 3, but not bigger than the 4th. Okay. FG is still longer than M. But GH is greater than D. GH right here is longer than D. Therefore, the whole length of FH is longer, FH is longer than D and M put together. Well, here it is. FH, the length of FH, is longer than D plus M. If we were to put the lengths of D and M together, FH would be longer than the 2 of them together. Okay? FH is longer than N. K is not longer than M. FG is longer than GH. Okay, and by saying all this, we can go ahead and finally say that the ratio of AB to D is greater than the ratio of C to D. So the ratio of AB to D is still greater than the ratio of C to D. And that's Euclid Book 5, proposition number 8. I will tell you more in a future video, so stay tuned.